Hey y'all, today we're going to learn how to multiply decimals. If you need to go back and watch my videos over adding and subtracting decimals before you watch this video, you'll need to know how to do that before you learn how to do this. So make sure you go back and watch that. Let's go ahead and get started. So there are a few ways to show what you know whenever it comes to multiplying decimals. You can use the standard algorithm, you can model it, or you can use the area model of decimal multiplication. For standard algorithm, there are a few other terms that might be used for that. Standard algorithm is what mathematicians call this method. You might have also heard it called the shortcut way, the stacked method, or if your parents are helping you at home, they might have said something about back in my day. So the back in my day method or old math or something like that. So that's something that maybe your parents or grandparents say. This is what they know how to do, if that helps you. So here are the steps to how we do the standard algorithm. On the next slide, I'll give you an example. But the first step is ignore the decimal at first. Count the total number of digits to the right of the decimal in the problem, which are the decimal place values. And then you move the decimal in the product, which is the answer to the multiplication problem. You move the decimal in that product the same number of times in step 2, but to the left. So let's practice. Okay, so let's put those steps into action. So we have 3/10 times 4/10. Let's get out of the habit of saying 0.3 times 0.4 because we're going to speak like mathematicians. So 3/10 times 3/4. So we are going to multiply like usual and we're going to ignore the decimals for now. So I know that 3 times 4 equals 12. Okay, but I look at the number of place values to the right of my decimal. So I have 1 place value, 2 place values. Okay, whenever I multiplied like usual, it's understood that my whole number always has a decimal behind it. But now I have to move the decimal in the product the same number of times that I did in step 2, but this time to the left. So I counted 1, 2, and I counted to the right. Now I'm going to move it 1, 2 times. So my real answer is 12 hundredths. Not 0.12, but 12 hundredths. A second way you can show decimal multiplication is to draw a model. So you're shading the first factor vertically, that's up and down. The second factor is shaded horizontally, which is side to side. And the third step is the product is the overlapping small cubes on the hundredths grid. So let's put our steps into action. So using the same factors from my first problem, I'm going to use them for my modeling problem too to show you how I can show your work a different way. So we have 3/10 times 4/10. And my first step is to shade my first factor vertically. Well, I like to assign colors to my numbers or my factors so that I don't get confused. So I'm going to use light blue for, well, it's hard to see it on there, but I'm going to use light blue for 3/10, and I'm going to use yellow for 4/10. And you can't really see that yellow. Let me try a different color. Maybe use green. So blue and green. So I'm going to shade my first factor vertically. So I know that this hundredths grid has 100 little cubes in it. So 3/10 or 30 hundredths is going to be 3 columns, which is 10, 20, 30. So you can be as neat or as messy as you want. It doesn't matter as long as your teacher and you can tell that that's what you're trying to shade. So there's my 3/10. I'm going for it. If you make like a horrible mistake, but you can still tell what you're shading, I encourage you not to get caught up in being perfect. Just as long as it's mostly shaded, that's good enough for a math model. Okay, so my 3/10 are shaded. So I'm going to go ahead and check that off, that I shaded 3/10. And now I'm going to shade my 4/10, and I'm going to shade that factor horizontally. So my first factor was up and down, which is vertically, and now I'm going to shade horizontally, overlapping. So 4/10, I know that a 10 by 10 is still 10 rows and 10 columns have the same number of blocks in each row and column. So I'm going to shade 4 rows all the way across because it's 10, 20, 30, 40 hundredths or 4/10. So 1, 2, 3, and 4. And the way that I find my product is to count up the overlapping cubes. Now, sometimes whenever you get to this part, it might be kind of hard to see. So you might want to outline the overlapping part. So I can tell that it's blue and green over here, and right here, right here, right here. Okay, so now I'm going to count the number of small cubes inside my overlapping area. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 small cubes out of 100. 12 over 100 is 12 hundredths. So the way that you would write that would be 0.12, but we say it 12 hundredths. And as always, make sure you circle your answer to help you stay organized and to help out your teacher. One of the final ways we can show decimal multiplication is through the area model. The first thing you do is split apart each factor into its place values. The second thing you do is place each of those place values accordingly on the outside of each box. The third thing is to multiply to find your partial decimal multiplication products. And the last step is add those partial products to find your final product using what you learned from adding decimals. So based on what we just did, if I did the same thing for all my boxes, oops, let me use a different color. If I did the same thing for all of my boxes, then I would get the following answers. So if you added up all of the boxes from our example, you would get 28 hundredths, 14 thousandths, 2 hundredths, and 1 10,000th. And the last step is to add together all of your partial products, make sure the decimal is lined up. You add like normal, and then you drop that decimal down. So there's nothing in the 10,000ths place except for a 1, so we get 1. I have a 4 and a 0 is a 4. I have 0 plus 2 plus 1, which is 3. And then I have, oh, you know what? I think I made a mistake. Sorry about that. So that's why it's important to make sure our work is organized. Should have rewritten it. So it should be 8 plus 1 plus 2, which is going to give me 11. And then I carry that 1 over to the 10th place, and I get 2 plus 1 plus 0 plus 0 plus 0, which is 3. And so my answer for that one is, so I'm not quite sure that's my answer. I think I might have made a mistake whenever I multiplied 5 hundredths and 2 hundredths. I added an extra 0. So I'm going to cross this out and rewrite so it's a little bit more organized. And you know, this might happen to you too, and that's okay. Sometimes you have to redo your work just to make sure that you have the right answers going for you. So I actually accidentally added an extra 0. That's a little messy. Okay, let's try it one more time, y'all. Sorry about that. We're adding together our partial products. So 4 plus 1 is 5. 8 plus 1 plus 2 is 11. Carry that 1. We get 2 plus 1 plus nothing, which is 3. and the decimal drops down. So my final answer is 315 thousandths.